Hello guys, good evening. तो लास्ट टॉपिक हमने क्या कर लिया था? ओके, तो टुडे वी विल स्टार्ट आवर नेक्स्ट टॉपिक, दैट इज बायोमोलिक्यूल्स. ओके, टुडे वी आर गोइंग टू स्टार्ट बायोमोलिक्यूल्स. ओके, तो बायोमोलिक्यूल्स, कैन यू टेल मी व्हाट आर बायोमोलिक्यूल्स? So biomolecules, as the name suggests, bio, molecules are lifeless. Okay, but those molecules which form the basis of life, means they not only build up living systems but are also responsible for their growth, maintenance and their ability to reproduce. Those are called biomolecules. Okay, so what do you mean by biomolecules? These are, yes, these are complex lifeless chemical substances. Okay, these are complex but lifeless chemical substances which form the basis of life. Those are called biomolecules. What do we mean by the basis of life? Because life is all about, what is life? We are growing, okay, we maintain ourselves, we have ability to reproduce. So these all things form the basis of life. Okay, so what it means? They not only build up living systems but are also responsible for the growth, maintenance and ability to reproduce. Okay, so there are various types of biomolecules, like, yes, tell me, like carbohydrates, even proteins, enzymes, nucleic acids, or yes, hormones, vitamins, they are all, yes, they are all biomolecules. Okay, even ATP, you know what is ATP? Adenosine triphosphate. Okay, these are responsible for storage and exchange of energy. So they are all biomolecules. Just Ashish, glucose is under the heading of carbohydrates. Glucose, fructose, sucrose, starch, cellulose, all are carbohydrates. Okay, starch, cellulose, sucrose, fructose, glucose, we will discuss these in the carbohydrate part. So let us start with carbohydrates. So biomolecules are simply, these are lifeless substances but they form the basis of life. Okay, so first part is carbohydrates. Now what are carbohydrates? So carbohydrate, as the name suggests, why these are known as carbohydrates? Actually, the name was given to hydrates of carbon. Earlier means they are supposed to be the hydrates of carbon, okay, because they have carbon, hydrogen and oxygen. So actually hydrogen and oxygen in most of the cases is present in the same ratio as in water, okay. So generally they can be represented as, general formula can be written as Cx and H2OY, okay. That is why they were known as hydrates of carbon, okay. But actually modern definition is they are actually polyhydroxyaldehydes or polyhydroxy ketones, and they are optically active. So old definition is why they are known as carbohydrates, because name was given originally because they were supposed to be hydrates of carbon. But now according to modern definition, what are the limitation of this old definition? There are a number of compounds like I can name one of them, deoxyribose. So deoxyribose is actually C5H10O4, okay. This is a carbohydrate, okay, but it cannot be represented as hydrate of carbon. This cannot be represented as hydrate of carbon. And at the same time, this is the first limitation of the old definition. Second is there are other compounds like if we have formaldehyde, okay, so formaldehyde can be written as CH2O. So it can be treated as hydrate of carbon, or even acetic acid. So in acetic acid it is C2 and H2O2, okay. So they are also can be represented as hydrates of carbon, and they do not behave as carbohydrates, but can be represented as the same formula. And carbon is not known to form hydrates. There is no hydrate of carbon. Okay. So these are the limitations of the old definition. What is the old definition? According to old definition, carbohydrates, the name was because of hydrates of carbon, but actually hydrates of carbon all cannot be represented, all carbohydrates cannot be represented as hydrates of carbons, but there are many other compounds which can be represented as hydrates of carbon, but they are not carbohydrates. And even carbon is not known to form hydrates. That's why old definition was discarded. Now according to modern definition, if question is what is carbohydrate, then you should write modern definition. Don't write old definition, because old definition has limitations, okay. So modern definition is they are, or we can write carbohydrates are optically, or we can say are defined as, or they are optically active, they are optically active polyhydroxy aldehydes or polyhydroxy ketones, or substances which give these on hydrolysis. Okay. These are optically active polyhydroxyaldehydes or polyhydroxyketones or substances which give them on hydrolysis. Okay. So aldehyde, it may be there are aldehyde or ketonic groups. They are not present as such, but usually exist in combination with the hydroxyl group of the molecule in the form of hemiacetal and hemiketal. You know hemiacetal and hemiketal we have done in aldehyde, ketones and carboxylic acid chapter. Means in carbohydrates, though they have aldehydic and ketonic group, but that aldehydic and ketonic group is not present in the free state. This is in the combined state with the hydroxy group. Okay. So that is either, if it is aldehydic, it is in the form of hemiacetal. If it is in the form ketonic group, that is in the form of hemiketal. We will write the structures, then you came to know. Okay, you will come to know. Okay, now let us classify them. So classification of carbohydrates. So carbohydrates, they are also known as saccharides. They are also known as saccharides. Saccharide, it comes from Greek word saccharon, which means sugar. So they are classified into 3 classes depending upon their behavior towards hydrolysis. So first one is monosaccharides. Mono, as the name suggests, these are the simplest carbohydrates which cannot be hydrolyzed to smaller molecules. They are simplest one. Okay, these are simplest, okay, simplest carbohydrates. Okay, which cannot be hydrolyzed to a smaller molecules. Okay, to smaller molecules. For example, yes, any example? They are actually, general formula is CH2ON. Okay, and the N varies from 3 to 7. For example, best examples are quoted by glucose, CH12O6, glucose or fructose. Okay, even ribose. So simplest one are those which cannot be hydrolyzed further. They are smallest carbohydrates. Okay. Second category is oligosaccharides. So oligosaccharide means, oligo means few. Literal meaning of oligo, that is actually Greek name, it means few. Okay. But cellulose is not the example. Cellulose is a polysaccharide actually. Okay. So oligosaccharide means these are the carbohydrates which on hydrolysis give 2 to 10 molecules. These are carbohydrates, those which on hydrolysis gives, yes, 2 to 10 molecules of monosaccharides. Okay. means if 2 to 10 monosaccharides are joined together, we get oligosaccharide. Okay. So, depending upon the number of monosaccharide molecules which are obtained upon hydrolysis, they are further classified as disaccharide, trisaccharide, tetrasaccharide and so on. Disaccharide means, yes, disaccharide, what it means? So, these are the molecules which upon hydrolysis give two molecules, okay, of the same or different monosaccharides. Two monosaccharides are formed. They may be same or different. Examples are, these examples are important because they are in the syllabus. Sucrose, maltose, yes. Any other example? Yes, anybody? Lactose, okay. So, these are the disaccharides. Like in sucrose, there is glucose and fructose. In maltose, two glucose molecules. In lactose, there is glucose and galactose. Okay. Yes, trisaccharides. Mono and disaccharides are important. Okay. Tri means, and these all disaccharides have formula C12H22O11. Their general formula is C12H22O11. Yes, tell me, trisaccharides. So, trisaccharide means which on hydrolysis give 3 molecules of monosaccharides, and these monosaccharides may be same or different. Yes, any example? So, keep in mind one of the example, that is raffinose. Okay, and this on hydrolysis gives one molecule of each glucose, fructose and galactose. Raffinose has 3 molecules, that is glucose, fructose and galactose. Okay, and its general formula is C18H32O16. Okay, and see, sucrose has glucose and fructose. Maltose, both are glucose. In lactose, glucose and galactose. Okay. Yes, tetrasaccharide. Yes, tetrasaccharides. These are the carbohydrates which upon hydrolysis give 4 molecules of the same or different monosaccharides. Okay. For example, yes, example is stachyurose. Okay. So, stachyurose, it on hydrolysis give 1 molecule each of glucose, fructose and 2 molecules of galactose. See, same type, it has 1 molecule of glucose, 1 molecule of fructose and 2 molecules of galactose. Okay, and its general formula is C24H42 and O21. So, you can compare, see, disaccharides, trisaccharides and tetrasaccharide. We can compare them. See, first one is disaccharide C12H22 and O11. Now, trisaccharide 18. Okay, C18 means we add C6, H is 32. So C6 H10 and O16. So O5. Next, tetrasaccharide. C24 means again 6, H42, that is again H10, हाँ बेटा, and O, yes, yes, O, बोलो बेटा, yes बेटा, O21. So O, yes बेटा बोलो, so again that means, what it means, that every time when we add C6H10O5, then it becomes next saccharide di, tri and tetra, right. से हर्षिल बेटा रेबिनोज, आई थिंक कोई रेफिनोज होता है, रेबिनोज, आई डोंट नो, रेबिनोज भी एग्जाम्पल है, ये तो मैंने सुना नहीं. तो टेल मी विच मोनोसेक्राइड्स आर प्रेजेंट इन रेबिनोज. रेबिनोज में कौन कौन से मोनोसेक्राइड्स होते हैं बेटा, can you tell me? Okay, now last one is polysaccharides. So polysaccharides means which one hydrolysis give large number of monosaccharides, those are called poly as the name suggests, and its general formula is, you know, C6H10O5, every time we are adding. So C6H10, बट बेटा राइबोज जो है दैट इज द मोनोसेक्राइड. C6H10O5N, this is the general formula. Okay, and common examples are starch, cellulose and glycogen. धरानी श्री गुगिला, बेटा आई डोंट नो तेलुगु. Okay, so these are the polysaccharides and N is 100 to 3000. Okay, now okay beta, but keep in mind raffinose. Okay, raffinose, if you would like then Google it, but raffinose is the authentic example, so best to keep in mind raffinose. Okay, now after classification on the basis of number of monosaccharides, okay, next classification is sugars and non sugars. sugars and non-sugars. As the name suggests, sugars means which are sweet in taste, okay, generally, okay, and they are crystalline solids, they are soluble in water, these are collectively called sugars, okay. So all monosaccharides and oligosaccharides, okay, they are all crystalline solids, they are soluble in water, and they are sweet in taste. You know the taste of glucose, okay. That's why they are called sugars. Okay, beta Dharani. So they are called sugars. And next is polysaccharides. Polysaccharides, they are generally amorphous solids. Insoluble in water. And at the same time, they are tasteless. That's why they are called non-sugars. So that is the basic difference between sugars and non-sugars. So keep in mind, all monosaccharides and oligosaccharides, they are crystalline solids, soluble in water, and sweet in taste. That's why they are called sugars. But polysaccharides, they are amorphous solids, insoluble in water, and tasteless. That's why called non-sugars. Okay. Next classification, that is reducing and non-reducing sugars or carbohydrates. So carbohydrates are also classified as reducing and non-reducing sugars. So say all those carbohydrates which contain aldehydic or ketonic group in the hemiacetal or hemiketyl form, they can reduce tolerance reagent or failing solution. So they are called reducing sugars. What I said, all aldehydes, sorry, all those carbohydrates. Which carbohydrates? Which contain aldehydic or ketonic group. In the hemiacetal or hemiketyl form, okay, and they reduce tolerance reagent or failing solution. They are called reducing sugars, okay, and which do not reduce these reagents, those are called non-reducing sugars. So let us discuss the examples. So keep in mind, all monosaccharides, either aldoses or ketoses, they are reducing sugars. But I said all monosaccharides, whether they are aldoses or ketoses, they are all reducing sugars. All monosaccharides are reducing sugars. It does not matter it has aldehydic group or ketonic group, okay. They are all reducing sugars. Now come to disaccharides. Says in some disaccharides, aldehydic or ketonic group, they are not present freely, they are not free, they are linked through their reducing centers, okay. When we discuss those structures, then you will come to know that what I have said. Say in disaccharides like sucrose, say that means first in monosaccharides like glucose or fructose, they are reducing sugars. Glucose has aldehydic group, fructose has ketonic group, but both are reducing sugars. Now come to sucrose. In sucrose, there is glucose and fructose. So aldehydic group of glucose and ketonic group of fructose, they are linked through their reducing centers, okay. So that's why they are sucrose is called non reducing sugar, okay. While others like lactose, maltose, in which aldehydic or ketonic group are present in the form of hemiacetal or hemiketal, they are called reducing sugars. They are reducing sugar. And all polysaccharides, they are always non-reducing sugars. See, all monosaccharides are reducing sugars. All polysaccharides are non-reducing sugars, okay. You know, starch, cellulose, glycogen, they are all non-reducing sugars, but in between disaccharides, oligosaccharides, okay, in that case they may be reducing sugars or non-reducing, and in our case we should keep in mind sucrose, that is non-reducing sugar, lactose and maltose, they are reducing sugars, that's it, okay. Got it? Yes beta, any doubt up to this? Any doubt? No doubt at all? Okay. So now let us discuss in detail monosaccharides. Monosaccharides. So monosaccharides are the simplest carbohydrates, you know, which cannot be hydrolyzed to smaller molecules. We have already done this definition, and they contain 3 to 7 carbon atoms, but they are of two types: aldoses and ketoses. So what it means? Aldoses means those monosaccharides which contain aldehydic group, and obviously aldehydic group is monovalent, so it is always present at one end of the carbon chain, it is always at C1. Ketoses, those monosaccharides which contain keto group, okay. And you know, keto group, that is divalent, so it can be anywhere along the carbon chain, or in all naturally occurring ketoses, keto group is always present at the carbon atom next to the terminal carbon, means at C2. Though this keto group, as it is divalent, it can be present anywhere in between the chain, okay. Okay, this is monovalent, okay. So it is always at the one end of the chain, but divalent it can be anywhere, but in most of the cases in naturally occurring ketoses, keto group is always present at C2, means next to the terminal carbon. Now say aldoses and ketoses can be classified as trioses, tetroses, pentoses, hexoses, according to they contain 3 carbons, 4 carbons, 5 carbons, 6 carbons, okay. Likewise, like if we are going to write aldotriose, aldotrioses. So aldotrioses means first of all it should have CHO group, it may have CHOH group and CH2OH group. Eight carbon can be beta. No. In monosaccharides, it is up to 7. Okay. Because 8 carbon, it is difficult to form the ring. Okay, that I let you know in the structural part. Okay. So aldotriose, this is the best example. Its molecular formula is C3H6O3. Okay. Aldotriose means it has 3 carbons. Aldo with the aldehyde group, aldotetrose, 4 carbons, aldopentose, so it has 5 carbons with aldehyde group, aldohexoses and aldohaptoses. Accordingly, you know, ketotrioses, ketotetroses, ketopentoses, ketohexoses, same molecular formula remains same. Okay, C3, so H6O3, okay, C3H6O3, okay. So next is C4H8O4, means we add CH2O, right? We are adding CH2O. Pentoses, C5H10O5, again CH2O, again it is C6H12O6, then C7H14O7. Okay. So these are aldotrioses or ketotrioses. Molecular formula remains same. Ketotetroses, ketopentoses, oh, you can write it in horizontal manner as well. Ansh, thank you so much for your donation. Ketohexoses, ketohaptoses. But better to write like this because it is always written in the form that CHO is at the top most oxidized carbon at the top and most reduced at the bottom. Okay, this is the way to write structures, but if you write in the horizontal manner, it's okay, you can. Harshil, got it? Yes, you can write aldo triose, tetrose, no need to write S. Okay, but I am writing because I am writing class. Aldo trioses, there are so many aldo triose. Okay, just plural of aldo tetrose. So, aldohexose you know all, glucose, mannose, galactose, all are aldohexoses. Okay. Glucose, mannose, fructose. Right. And what about ketohexoses? Like best is fructose, because glucose and fructose we are going to discuss their structure, their preparation. Okay. So, that is all for the day. Today we have discussed what are carbohydrates. These are biomolecules. These are simply complex lifeless molecules which can form the life. And then we have covered definition of carbohydrates. Carbohydrate old definition is they are hydrates of carbon, but that do not include all the molecules, or even other molecules are also included in hydrates of carbon, though they are not hydrates of they are not carbohydrates. Okay, that is why modern definition is these are polyhydroxyaldehydes or polyhydroxyketones, or the substances which give them on hydrolysis and they are optically active. And then we have classified on the basis of monosaccharide, disaccharide, trisaccharides. Oh sorry beta, मैं change कर दूंगा अभी, है ना. And monosaccharide means which cannot be hydrolyzed, they are the simplest molecules. Oligosaccharide which can give 2 to 10 molecules of monosaccharides. Di, tri, tetrasaccharide we have discussed. Then polysaccharides which on hydrolysis give large number of molecules. Okay. Then we have covered sugars and non-sugars. Monosaccharides and oligosaccharides, they are sugars, they are sweet in taste, they are crystalline, they are soluble in water. And polysaccharides are non-sugars because they are amorphous, they are insoluble in water, they are tasteless. Then we discuss reducing and non-reducing sugars. Reducing sugars are those in which there is aldehydic or ketonic group in the hemiacetal or hemiketal form. Okay, and they reduce tolerance reagent or failing solutions. And non-reducing all monosaccharides are reducing sugars, all polysaccharides are non-reducing sugars. Disaccharides, best example sucrose, that is non-sugar, a non-reducing agent, sugar, and lactose and maltose, they are reducing sugars. Then we have classified monosaccharides, aldoses and ketoses. Okay, so thank you so much. Bye bye beta. Okay.